So today we're adding two more triangle similarity shortcuts. So the first one is SSS, side similarity. If you can prove that corresponding side lengths of two triangles are proportional, then the triangles are going to be similar. You don't have to know any of the angle measures, but if we can say that the scale factor for each pair of sides is the same, we know that those figures are going to be similar. And then the second one is SAS, so side angle side. Here you only need two sets of proportional sides, and then you need to know the angle between them is congruent. So we've got SSS, SAS, and then from yesterday, angle for our three triangle similarity shortcuts. So we want to determine whether these triangles are similar, and if so, we'll write a similarity statement. So you're going to have to look for any of those shortcuts. Here I'm given three sides, so let's test out and see if SSS works. So we just have to test the proportions between each side. And you're just going to have to take your best guess as to which side lines up with which other one. I'm going to say like AB corresponds with XY. So 6 divided by 12, that would be 1/2. If you went the other way, it'd be 2/1, and that'd be fine. Just be consistent. AC looks like it goes with XZ. 9 divided by 18 would also be 1/2. And then BC looks like it goes with YZ. 4 divided by 8 would be 1/2, so we are good. We know those triangles are similar by the SSS similarity shortcut. So now we can write our similarity statement just like we write a congruent statement, only we've got a different symbol in the middle. Triangle ABC is similar to triangle, make your corresponding parts line up, XYZ. All right, on the right, it looks like I'm given two sides and an angle between them. So let's test if the SAS shortcut works. Again, you're just going to kind of have to look at it and guess which parts go with one another. Looks like to me that JL is my longest side. So that looks like it'll pair with WX. So let's see, 36 divided by 24. We can reduce that to 1.5. I just threw it in a calculator. And then it looks like KL would correspond with WY. So 20 divided by 18. That would be 1.1. Those are not the same proportionally. They've got a different scale factor, so those triangles are not similar. And then last thing we're going to do is determine whether these triangles are similar with ordered pairs. I did put a graph here. You don't necessarily have to use a graph. You should be able to do this just on a piece of notebook paper, but I like to visualize it first because sometimes if you make a graph and you look at it, you'll be able to tell right away that there's no way that they're actually similar and you won't have to do any calculations. So we've got triangle RST. R is at 1.5. -1. S is at -3.5, 1. And T is at 3, -2.5. It's not a very pretty triangle, but that's what it looks like. And then we've got triangle UVW. So U is going to be at negative 2, 3. V is at 2, 6. And W is at negative 5, 5. So this might be one where just by looking at it, I would be able to tell, no, those triangles aren't similar. There's no way that they have the same angles. But just to be safe, I'm going to actually do some calculations so that we know how to do them. So you can't really test for either angle or SAS on a graph. You only can if you see that it's very clearly making like a right angle. So the only similarity shortcut we'll be able to use here is SSS. So we have to test if the three sides are proportional. And it ends up being quite a bit of work. We want to see if triangle RST is similar to triangle UVW. So we're going to have to basically test every single side length in a proportionality statement. So first thing, let's check segment RS compared to segment UV. So I'm going to have to find those distances. So RS would be the distance between point R, which is at 1, 5, or 1.5, negative 1, and S, which is at negative 3.5, 1. So our distance formula is the square root of x1 minus x2 squared plus y1 minus y2 squared. So I'm going to find the distances between my two x values. From 1.5 to negative 3.5, that would be a distance of 3.5 plus 1.5 would be 5. From negative 1 to positive 1, that would be a distance of 2. Take those two numbers, square them, add them together, and take the square root. So I've got the square root of 25 plus 4 would be the square root of 29. If you like decimals, we'll call that 5.39. So that is RS. We're also going to need UV. So U is at negative 2, 3. V is at 2, 6. So I got to find the distance between my x's. Negative 2 to positive 2 would be a change of 4. 3 to 6 would be a change of 9. Take those two numbers, square them, add them together, take the square root. So 4 squared would be 16, 9 squared would be 81. That's the square root of 97. Which would be, we'll call it 9.85. All right, so there's one of our sides to check for proportionality. Let's say RS divided by UV. Square root of 29 divided by the square root of 97. I got about 0.55. So now we have to test another side pair and see if it ends up being the same. If it's different, we can stop. If it's the same, then we're going to have to test a third side pair. So it looks like segment ST is going to correspond to segment VW. So let's test those. So S is at negative 3.5, comma 1. T is at 3, comma negative 2.5. Let's go ahead and find this distance. Negative 3.5 to a positive 3 is going to be a change of 6.5. 1 to negative 2.5 is going to be a change of 3.5. So those are my change in x's. I'm going to square them, add them together, take the square root. So 6.5 squared plus 3.5 squared, I'm going to get the square root of 54.5. If you like decimals, that is about 7.38. And that one was ST. And then we want to compare that to VW. So V is at 2.6 and W is at negative 5.5. Distance between x's, 2 to negative 5 is a change of 7. 6 to 5 is a change of 1. Take those numbers, square them, add them together, take the square root. So 49 plus 1 would be the square root of 50. If you like decimals, we'll call that 7.07. All right, now we have to figure out our proportion. So it looks like before I put RS on the top and UV on the bottom. So here I'm going to put ST on the top and VW on the bottom. So we got ST over VW. So the square root of 54.5 divided by the square root of 50 is 1.044. My proportion before was 0.55. So I have two different numbers. That means that the SSS proportionality shortcut would not work on these triangles. So no, they are not congruent. So again, these problems end up being quite a bit of work. You don't have to make a graph, but I generally like to sketch one beforehand because, like I said, with this one, if I had seen that graph, I would have said, oh no, there's no way that those two are proportional. They don't look like they're the same triangle. And I would have just said no. But if you didn't have a graph, you wouldn't be able to do that.